My name is Natalie Sebastian, and I'll be going over how to perform a local DNS attack. For this attack, we need 3 VMs, one being the victim at the .7 address, the second one being the attacker at the .5 address, and then the DNS server at the .12 address. So first I need to set up the local DNS server on the victim's machine. So I'm going to go to network connection and then click on the wired connection to verify that the device's MAC address matches the MAC address of the VM. So once I do so, I go to the IPv4 settings and put the DNS server's IP address in that box. Then I hit save. Next, I'm going to go to this directory here to edit the header file to make sure that the DNS server is assigned as the name server. So here I have name server set to the DNS server's IP address. And then after I do this, I'm going to execute this command here in order to implement that into the resolve config file. So this is adding the contents of the head file to the configure file in the etc directory. And then when we go to that directory and view this file, we can see that the name server of the DNS server's IP address was successfully added. So now that I executed this, I'm going to execute the dig command on a www.example.net in order to see if the settings were successful. And before we set the server settings, the server should have said 127.0.1.1, but since I made the settings connecting to the DNS server, we can see here at the bottom of the server's IP address is the server of my DNS server VM that we just configured. Next, I need to set up the DNS server. So in order to do so, I executed the ifconfig command so we could see that the IP address was the .12 address. Next, I need to go to the following directory to view the names.com.options file so that I can ensure within the options block the dump file has the following extension that will be shown here. This command specifies that the cache content to be dumped to the location. And this was already pre-configured in the VM. It can be seen down here in the dump file. And then there's the extension to the dump.db. So now I can try to ping google.com, and then while executing these pings, I'm going to have Wireshark open so that I can see the multiple ping requests and reply packets in Wireshark. So I have Wireshark ready, then I ping google.com, and when I go back over to Wireshark, we can see all of the ping requests and replies. And I am also able to do this on the victim's machine as well. So lastly, I needed to construct DNS packets on the server using scapy in the dnsserver.python file. So first, I need to create a directory called the book code. So here we can see the book code directory, so I'm going to go to the book code directory. Within here we have DNS, so I'm going to go there next. And then after that we have the DNS _construction _scapy directory. So within here I have my dnsserver.python file. So first I'm going to chmod an a+exes to compile it, and then I'm going to run this file with www.google.com after it. So once I execute this, I'm going to go back to the user machine and I'm going to type in this following command, dig at the DNS server's IP address with port 1053 at google.com, and we can see here that it says google.com and then this is an IP address given with it. So this shows a constructed DNS response. And then when we go back here, we can see that. So now that everything's configured, we can begin to perform a DNS cache poisoning attack. So first, I need to flush the cache, on the attacker machine, the server machine, and then on the attacker machine I'm going to create a file called task6. So this Python file will launch the attack by sending out poison DNS packets. So we have this set to the IP address 1.2.3.4, which we'll end up seeing on the victim, and then the source host is set to the DNS server at port 53. So next, once I execute this command, I'm going to go back over, and once it's running, I'm going to go back over to the user machine and execute the dig command on the www.example.com. So once I execute this, we'll see that the name server for this address was changed to 1.2.3.4 due to the attacker's file because there was an answer section entry in the task6 Python file with the IP address set to 1.2.3.4. So now I'm going to head over to the server's machine and execute the following command to clear the dump DB's cache. And once I do that, I'm going to open getEdit on the dump.db file to view the DNS server's cache. So here we can see similar results that we saw on the user's machine. But we can see that the 1.2.3 address was assigned to the example.com just like shown on the user's machine. Now I want to perform an attack against the authority section. So in order to do so, I'm going to copy the task6 file and rename it task7 so I can perform the edits necessary. So once I copy it over, I'm going to edit the task7 file. And in order to direct this attack at the testing authority, I need to add an authority section entry represented by nsec. So I'm going to put that in right after the ansec line. And I'm going to change the ansec line to the victim's IP address instead of 1.2.3.4. So here I'm going to write the nsec. I'm going to set the RR name equal to example.net with type NS, and then it'll have the same TTL as the ansec section, and the R data field will be attacker32.com. And in order for this line to be called, I'm also going to need to add ns equals nsec at the end of the DNS packet command, just like an equals assec. And I'm also going to need to add an ns count equals 1 to the same command. Alright, so now I'm going to go ahead and add the ns count equals 1. And then I'm going to add ns equals nssec. So once I do this, I can go ahead and hit save. And I'm going to compile this code. I'm going to use sudo to compile this code. Okay. And now I'm going to perform the flush functions again on the server. On the victim, and on the attacker. So now I'm actually going to run the task7 Python file. And similar to the previous step, I'm going to go back over to the user's machine, and I'm going to execute the same command, dig www.example.com. And this time we can see that the answer section, change the IP address to .5, and that an authority section was added with the example.net and attacker32.com. So now I'm going to go back to the server side and perform the same commands to flush the cache of the dump file, and then view the DNS server's cache to see if the results were the same as the output onto the victim's machine. So here you can see that the results are the same as we saw on the user, and that our attack was successful in targeting the authority section. Now for task 8, I need to target another domain. So in order to do so, I created another Python file called task 8. And so now, instead of just having nsec, I made it nsec1 so that I could add a second nsec2. So the first one is the same, and the second one has google.com with the name server as attacker32.com. So because of this, I also needed to change the ns count to be 2, and I changed ns to be nsec1 and nsec2. So once I save these changes, I compile the code again. And before I do this, I needed to flush the attacker, flush the victim, and then after this I'll be flushing the DNS server as well, because this needs to be done each time to make sure that the cache is reset so that the attack can be successful. So now I'm going to run the task 8 file, and then go to the user machine to execute the dig www.example.net. So here I can see the example.net was sent with attacker32.com, but we're missing the google.com section as well. Now, everything I implemented in my code was correct, so we really should be sending the google.com here under example.net and attacker32.com under the aforementioned attacker32.com. So I'm still going to perform the same functions on the server and check the DNS server's cache file. Unfortunately, it isn't showing the google.com entry, it's only showing the other entry. So for the last task, I need to target the additional section. So in order to do so, I created a task 3 file, and we can see that the ansec and nsec1 are the same, but for nsec2, I changed the R name from google.com to example.net, and I changed the R data to ns.example.net. And I added 3 additional sections. The first one with attacker32.com to 1.2.3.4 IP address, the second one to ns.example.net with 5.6.7.8 address, and the third one with facebook.com with 3.4.5.6 address. So because I added these 3 additional sections, I also needed to add an AR count set equal to 3, and AR equals the 3 add sections at the end of the DNS packet command. So once I did so, I saved the file, and I compiled it. And then I'm going to perform the same functions I did for the previous few tasks, making sure that I flush each of the 3 systems, and then once done so, I can begin to run the attack. So here I'm going to run the task 9 file. And then I'm going to go over to the user and execute the dig command again. And so here we can see that the authority section is correct, it's showing everything, the answer section is, but the additional section is only showing 2 of the entries. So it can be seen that the other entry wasn't included, and that is because these 2 entries had the same name servers corresponding to the authority section. The other one had facebook.com. which doesn't relate back to any of the other entries in the authority section. So because of this, that entry was not successfully cached. As you can also see here in the server, we only see the same entries that we saw on the user machine. Now I'm going to be going over how to perform an ARP cache poisoning attack. So here I have the server machine and I ran the ARP request, so we can see that .5 is the attacker's MAC and that .7 is the user's MAC. And then the same thing here on the user machine, I ran the ARP command so I can see the server's MAC address and then the attacker's MAC address. So now I'm going to go to the attacker's VM and I wrote a piece of code here to create an ARP request that's going to be sent to host A, and then I'm going to check to see whether M's MAC address was mapped to B. So A is the attacker, A is the server, B is the user, and M is the attacker. So I'm going to get Wireshark ready so we can see the packets once I run the command. So I'm going to compile it, and then here I'm going to run the script, and it sent one packet, and we can see here in Wireshark that it sent an ARP request. So now I'm going to go back to the server machine and I'm going to perform the ARP again and compare the results. So now we can see that the MAC address of the user is the same as the MAC address of the attacker. So the ARP cache poisoning was successful. So I went back to the user and the server's machine and I reset their cache so that the victim machine has its original MAC address again, which we can see here. The .7 is back to its original MAC address. So now on the server machine, I made an edit to the code where I added the A.P destination, and I'm setting that equal to the IP address of the server so that in Wireshark we'll see the IP address in the packet. So once I run this command again, we can see the packet was sent, and it is another request, and here we can see the IP address of the server. Now going back to the server machine, when I run the ARP command again, we can see that the MAC address of the victim has been successfully poisoned again to the attacker's MAC address. So I cleared the cache on the server and the user machine again so that the user's MAC address was set back to its original value. And now I went back over to the server and I made some edits. Now the P destination is set to the gateway IP address at 10.0.2.1. So I'm going to compile it and run it again and view the packets we see in Wireshark this time. So now that the packet's sent, we can see that there is another ARP request sent and the IP address is showing the gateway's IP address. Now I'm going to go back over to the server and execute the ARP command again to compare our results. And as we can see again, the attack was successful and the user's IP address was changed to the the MAC address. So now that I've shown you ARP request, we're going to do an ARP reply. So now that I reset the user's MAC address back to its original value, we're going to go back over to the server and we're going to make an edit in the code to set the A.op equal to 2. Now this is going to send an ARP reply as opposed to the previous few examples which have been ARP requests. So I'm going to open up Wireshark again and then compile and run this file. And this time we should see an ARP reply. Then we click on it and then you can see that it does say reply. And now when I go back over to the server, I'm going to run the ARP command again to see if the attack was successful. And it can be seen here that the attacker's MAC address was successfully changed to the attacker's. So now I'm going to try to perform the attack using an ARP gratuitous message. So I reset the user's IP address, MAC address, back to its original value, and here I set the destination to the broadcast MAC address. And this is going to give us the gratuitous message. So I'm going to compile and run this file while I have Wireshark running so we can compare the difference in packets. So once I run it and the packet is sent, we can see here that it says a gratuitous message. And when I go back over to the server and I run the command, we can see that this type of ARP is not successful in performing the cache poisoning. So now I'm going to be performing a man-in-the-middle attack on Telnet using ARP cache poisoning. So I reset the victim's MAC address back to its original value, and I made edits to the code on the attacker. So now we have double the code so that we're cache poisoning both the victim and the server. So when I compile and run this, it sends 2 packets instead of 1. One to the victim and one to the server. So when I run the ARP command here on the victim, and then I'm also going to come over here and run the ARP command on the server, and we can see here that the user's MAC address was successfully changed to the attacker's because it no longer matches its old old MAC address ending in 75. And then when I go back over to the user, we can also see that the server's MAC address was also changed to the attacker's MAC address, showing that the attack was successful. So due to this attack, neither victim or server should be able to ping to each other. So I'm going to test that here, and we can see that the user was not able to ping to the server. And I'm going to try the same thing on the server side, and we can see that the server is also not able to ping the user. So now I'm going to turn on IP forwarding on the attacker machine, so it will forward the packets between the victim and the server. And by executing this command, the server is now able to successfully ping to the victim, and the victim is able to successfully telnet into the server. So now I'm going to set the IP forwarding to 0, so that when the telnet connection is successful, the attacker will be able to send a fixed character Z regardless of what the user typed on their screen. So once there's a successfully telnet in, I type the letter A and it immediately types in a Z, showing that the man in the middle was successful.